Future Current. I'm your host, Sean Swentek. Today I'm joined by Bruce Anderson, CEO of 24/7 Solar. Hey, Bruce, thanks for joining me today.
Thanks, Sean. It's my pleasure.
Now, Bruce, you were writing the book quite literally on solar energy back in the 1970s. For my younger listeners, that was the previous decade and generation that you might not even be aware of existed in solar. And you were dubbed Mr. Solar in the 80s. You've seen multiple boom and bust cycles. They call this the solar coaster for a reason. How has that 40-year perspective shaped the bet that you're making right now with 24/7 solar?
Boy, that is a great question. Way back then, I had to spell the word and define it when I'd be talking to Rotary groups or something like that, and I didn't think it would take this long to get to where we are,
Yep.
but I knew we had to get there or the planet wasn't just going to support us anymore. And I think we see that in spades. But there's no stopping at this point. I mean, it's reached a tipping point. Clean energy is not only the lowest cost approach and the quickest to deploy, but it also has the promise of a much cleaner and healthier future, not just for the planet, but for people who don't have to drink dirty water from, let's say, steel refining or don't have to breathe dirty air from everything. It's hard to imagine a planet that's as clean and beautiful as it was before people, but with people living in it. That's the vision.
I love that. I think that's the reason a lot of us get into this space. Beautifully put. A lot of my guests, Bruce, are in the more traditional avenues of solar and battery storage. You work in concentrated solar power. At least that's the business of 24/7 solar. Let's just tackle the elephant in the room right away. I think CSP can bring to mind for some folks recent high profile struggles like Ivanpah out near me, Crescent Dunes, etc. Large capital outlays, complex molten salt plumbing reliability issues.
Yeah.
When you walk into a room to pitch concentrated solar power today, how do you dismantle that scar tissue and sort of have people start fresh with you?
Well, it really depends where in the world I'm talking. In the United States, I have to avoid the term CSP, but most places in the world, they actually embrace it. And they embrace it because of its basically its value proposition, what it offers. As an alternative to batteries and PV and wind, which don't operate, when there isn't sun or wind. And then you need a backup that comes from where, we conceived of this solution, one, to solve the issues that have addressed CSP, and there are many, but the other is to basically deliver the energy that people need, which is 24 hours a day, not just when the sun shines or the wind blows. That's the only way we can get to a clean energy future is to have it all the time, every hour of the year. And that's how we conceived it, and that's how we present it. But when we propose and engineer solutions for customers, which are usually industry and utilities, almost always they're hybrid solutions. By that I mean they combine our system with PV and or batteries and or wind as the way of getting the lowest cost, most integrated and acceptable solution to the customer. So we don't think of ourselves as instead of, but we're very complementary.
I love that. Now, Bruce, some of my listeners might not know as much about CSP, and they might look at your name of your company, 24/7 Solar, and say that's an oxymoron. Solar is in the name concentrated solar. Tell us about how it becomes 24/7 if it's dependent on solar, because I think some folks are wondering, yeah, it's concentrated, great, but how does that translate to 24/7?
Well, that's a very reasonable question. And that brings me back to the fact that our solutions are hybrid. And typically what we do is use PV panels, PV, during the day because it's cheap. And when the sun's out, it's dependable. And sometimes we add batteries just to make sure the power supply is pretty steady during the day when the sun goes in and out of clouds and that kind of thing. But then during the day, we store all the sun's energy as heat, not as quote electricity in battery. In a sense, our battery is basically a silo kind of format, and it's filled with small pieces, like we call them pellets of ceramic. We use our technology to heat air, ambient pressure, atmospheric pressure air, up to 1,800 degrees Fahrenheit. almost 1,000 centigrade. That's hot enough to not melt, but soften steel. And the ceramic is something that withstand temperatures well above those temperatures. And then we just use blowers to circulate it. So we store all the heat at night in that ceramic, and then we use other blowers to pull that out at night and deliver it to a a turbine. They're called gas turbines or air turbines. They're like jet engine
Mhm.
turbines, but instead of using combustion, we use air, that hot air, to drive the turbines. So we produce electricity without combustion. And like all engines, this turbine gets hot. Some of that energy goes into heating the turbine. And so, the turbine has an exhaust, and we can use that heat to drive an industrial process.
Wow. So pretty darn cool. To go one layer deeper on the tech, traditionally in a lot of this space, they would use something called the Rankine cycle, which was steam. You're moving to the Brayton cycle, hot air, like you just described. For the non-engineers listening, like myself, why is that shift from steam to air the critical unlock for reliability and cost?
Well, steam turbines of almost any size require somebody right there in the event they stop.
Hmm.
'Cause they've got kinds of reasons for not necessarily breaking down, but time of day, time of temperature, all kinds of things can affect the operation of a steam turbine. There's a reason that jet engines use Brayton cycle turbines. They're dependable.
Yeah.
They're reliable. You turn them on, they go for hours, days, years without having to have any attention whatsoever except maybe change out a filter. So they really increase the reliability. They reduce the operating costs. And in our case, we get to use just ordinary air to heat it up high to drive them. And the other thing is that with these kind of turbines, they can be made smaller than Rankine cycle steam turbines and still be effectively efficient. And so one of the ways in which we avoided some of the problems with CSP, besides using air, which eliminates a lot of them, is to make them smaller and modular. That might bring small modular reactors, SMRs. They got the same idea. They said, these big construction project, these huge nuclear plants take forever, cost a lot, and have a lot of potential issues. So they're making smaller, modular, standardized factories, and that's what we did. But we started a long time ago.
Wow, that's exciting. We're seeing obviously a pretty massive saturation of PV on the grid today, right? There's incentives and low cost of the actual equipment has allowed it to really proliferate and to the point of negative pricing sometimes in places like California and other places with a lot of sun. The standard rebuttal is PV plus lithium ion or some type of battery storage will ultimately win everything. But I would imagine for you, you probably could explain that at some point the economics of PV plus battery begin to break down. So where does your thermal storage sort of pick that up and carry it home?
Well, right now, it's hard to make a case anywhere in the world for more than 4 hours of batteries.
Yep.
And that's pretty good. The number will increase. That number of hours will increase as the cost comes down.
Mhm.
We sized our system to operate from the time that the PV system starts delivering less electricity because the sun is it's coming at the end of the day until it starts up again in the morning. And that requires anywhere from 12 to 18 hours of storage. And our storage is much cheaper than batteries. So regardless of what the electric batteries do in the future, ours will operate the entire night. And then something that I know some of your listeners or viewers have asked themselves and wish you would ask, because you asked that question about why are we 24/7? Well, the reality is that everywhere in the world, even the Atacama Desert, has sunless days. Sometimes it's bad weather, sometimes it's not. But, New York City, for example, does not want a day or two of sunless weather and no electricity along with it. And that's what you get with PV and batteries and wind and batteries.
Mhm.
You get those days where you still need a backup system. Well, ours inherently has a backup system because of those turbines. And as I said, we drive those turbines not with a combustor, but with air. But the difference between batteries plus PV or PV plus batteries is that when those batteries are empty, you're done. You need it
Yeah.
back. And when our heat storage is empty and there's no sunshine, we're not done. We keep operating because we've added a called an external combustor that when the air from the storage is not high enough, the combustor automatically turns on.
Yep.
Now today, we can't claim that we are carbon free when we do that because the world hasn't caught up to making acceptably low cost or acceptably costed
Yep.
alternative carbon free fuels such as green hydrogen. But it will someday. And these particular turbines, which will operate for 30, 40 years, that combustor can easily be switched over to another fuel such as green hydrogen in the future.
I love that. Love to hear that. You got me thinking too when you mentioned longevity. I gotta imagine your version of storage, this thermal system with ceramics, probably has got a pretty long lifespan versus say a lithium ion type chemistry.
Longer than you and me,
Yes. Wow.
easily. In a prior company, we tested the same ceramic through hot and cold cycles, heating it up to 1800 degrees and cooling it real fast and so on. We put it through 2 million cycles. And you look at that piece of ceramic, couldn't even tell. It's a ceramic that's actually very similar, if not identical, to the ceramics that's used in your exhaust system to reduce emissions. And, that just cycles and cycles and holds up forever. So you're right.
I don't think I can do the math that quick, but that feels like a couple hundred years, basically. Really, that's pretty amazing. You talked about the idea of atmospheric pressure that drives the air into the ceramic storage, rather than say pressurized loops that are employed with molten salt. Can you walk us through the physics or really the financial story because of those physics that helps lower the capex and the opex through O&M so drastically?
Yeah, there are a couple things that drive the lower cost. First of all, we're talking about mass production. The success of PV and wind when we first invented the system is what convinced me to have as our invention and engineering mantra factory production, standardization, rather than customization for every single power plant you build. So all of our power plants are identical, have identical modules. They're modular, just like a wind turbine is modular. I really think about it. You don't put one giant turbine out there, you put a bunch of them, a dozen or 2 dozen or whatever it is. And that's the same thing with our system. The reason that the wind does that, of course, wind turbines, because you can't get them much larger, but the mass production does drive the cost down. And also the simplification. All we have for moving parts are blowers and dampers. And when you have corrosive elements like molten salt, which is used for heat storage in conventional CSP, but I like to call my grandparents CSP, that can be a real problem. Also has environmental consequences when it leaks. And then, of course, the enormous amounts of water that are required in a Rankine steam turbine. You get the most sunshine in most arid areas in the world. That's the way it is.
Yeah.
No rain when there's lots of sun. And so water's a premium in areas where you have a lot of sunshine. So not requiring water means that you're a good environmental neighbor and that you're not stealing or outbidding the cost of the water from your neighbors. And these are really all critical. And not having we haven't identified a single environmental problem with our system, which means that environmental impact statements can take a year or years to get approved through a system. And we don't have any.
You mentioned this briefly earlier. A lot of focus has been on decarbonizing electrons, electricity. That's sort of the easy part, if you will.
Yep.
You kind of mentioned steel, so decarbonizing industrial heat for purposes like steel making. That's really the big question mark and sort of a headache for folks trying to solve for this. I think a unique feature of the Brayton turbine design is the ability to output that high grade industrial heat alongside power. How does that dual revenue stream change the project finance
Oh,
model compared to like a standalone solar?
Thank you for mentioning that because that was another item I was going to mention in response to your previous question. Whenever you're producing something that has a dual use or gives you two revenue streams at the same cost, your economics are going to get much better. And so all of our initial projects so far, the customer does want the heat. And so we're selling both electricity and heat, and that's what makes us very financially attractive. And of course, the other thing that happens with industrial customers, and when you think about it, it's not a surprise. If they if they use conventional solar, which operates only 22% of the time, a
Mhm.
number of hours per year, and they say, okay, I've reduced my energy costs a little bit, 22% of the time. I've reduced my carbon emissions 22% or more or so. And, like it's not quite so what, but it's like now what? They have no idea how they're going to get to 100%, but they know they have to, and not have to in the sense of somebody, hanging over them, trying to force them to, but because of the nature of society by 2035, 2040, if you're not doing that, you're just not part of the party.
Now, dual income stream from a single cost is probably good enough as is, but for listeners like me who might be wondering, are there additional incentives that CSP and the work you're doing here are entitled to? I haven't gone deep enough on the tax code to know if any of the work that you're in it hits any of those tax incentives.
Well, if there were still tax incentives in this country, we are totally eligible for them. We don't see any tax incentives outside of the United States,
Got it.
and that's where most of our business is.
Hmm.
So we're doing this without government subsidies or tax
Wow.
breaks all over the world. The other potential revenue stream are carbon credits. And of course, we're students of that opportunity. It's not well developed yet, but it's developing quickly. And that'll be a third revenue stream.
Well, the uptake without incentives just goes to the bottom line. This just makes financial sense, it sounds like, for a lot of
Yeah,
people.
it does.
That's exciting. Speaking of those people, who is the ideal customer for this heat application that we were talking about earlier? Are we talking like remote mining operations? Are you seeing traction with industrial players or even data centers that might be looking to get off natural gas? I know data centers is on everyone's mind right now. So, who is the ideal customer?
Well, you just listed them, but also making green hydrogen using silicon oxide electrolyzers or purifying, desalinating water using both heat and electricity.
Interesting.
But our go-to beachhead market are off-grid mines for a whole slew of reasons, not the least of which they pay more than anyone else in the world for their electricity, and we focus on those that also use heat to process their ore on site. So they get a double whammy benefit, financial benefit. They also understand machinery and they're not scared by it. But any industrial process that actually makes something, almost any, uses hot something, hot air, hot water, fluids of some kind. I mean, even processing food, they have to sterilize everything all the time, constantly. Takes a lot of heat. Data centers is a favorite topic. And the reason is that right now, we can deploy immediately. We don't have to wait for some future development of technology. We are lower cost than anything else out there, regardless of whether it's the grid or anything else. And our reliability is exactly what they need. We can offer like 5 nines reliability because of the redundancy of modules
Hmm.
in a system. If one goes down, you've got another 100 of them. And what's often not talked about is that they need really high quality electricity.
Hmm.
And these small turbines not only provide very consistent in a small range of of the various electrical outputs that you need for a data center for anything. So it's called very clean, but because they're small turbines, they can very carefully respond very quickly to the changing demands of power needs of a data center, which is also essential for maintaining that quality. through the ups and downs of the demand. And one way that we get to a real financial benefit to them is that we can use the heat from our turbines, and we can provide the chilling that they need to cool the liquids that they use to cool the chips.
Oh, wow. Okay.
Usually those chillers are electrical, and
Mhm.
they can require anywhere from 30 to 40% of the total electrical needs of the data center. Well, we get rid of that 30 or 40% of their electrical needs. We deliver the chilling using the heat from our system on a chiller that is driven by heat, not electricity, which is very, very common. It's off the shelf. Every mechanical engineer understands them. Very straightforward, highly reliable. But we've got a great value proposition for data centers.
That's incredible. Now, for many, moving from a university research spinoff to like steel in the ground, real business is that classic valley of death for hard tech. Granted, not everyone is doing that research at MIT where you study, but you have a pilot system planned in India. So, I mean, this is getting pretty real. What is the biggest bottleneck you're facing right now in moving from that pilot data to bankable utility scale projects?
Well, there are a lot of chasms to cross
Hmm.
when you're a startup, particularly a startup that's doing stuff and not software and big stuff, mechanical stuff, because you're talking about cost, talking about a lot of money. And so trying to attract venture capital to a new power plant concept that costs a lot of money is very difficult to do, and it's taken us a long time. But finally, the CEO of one of the 20th largest utilities in the world happens to be located in India. The CEO came to us and said, "Look, we are putting in 17 gigawatts, which is a lot, of
Wow.
PV every year." Says, "But we're also building 17 gigawatts of coal."
Gosh.
He said, "Because when the sun goes down, we got to turn the coal plants on. What else
Yeah.
are they going to do?"
Yeah. They need the energy.
Said, "We need something that operates all the time." And so instead of requiring us to go out and get money from investors, we have to build a pilot plant. We're building our pilot plant as as the initial commercial project for that utility company. And in exchange, they're signing a 25-year power purchase agreement. And so, they did their technical due diligence. They felt comfortable with this. And so now we're off and running with a whole bunch of other potential customers.
That's really exciting. Congrats, Bruce. So, speaking of your business model, are you, and maybe it's going to vary side by side, but are you planning to be like the OEM and EPC installer of these systems to developers and utilities, or do you foresee becoming an independent power producer yourself and owning and operating these assets long term?
We are selling energy. That's the short answer. We sell energy rather than systems. And so when we go to prospects, we say, you don't have to spend your own money. You just sign a power purchase agreement. We take care of everything. We guarantee delivery, and we show them how with all the backups and redundancies and the ability to burn fuel if the solar doesn't work. And, the risk is really low for them. And then we form what are called special project vehicles,
Yeah.
SPV in the lingo. And this SPV buys the system for that customer from us. We form that SPV, so we're basically managing another company in a sense.
Mhm.
And then we take responsibility for everything, the construction, obviously engineering, construction, and then managing and taking care of it afterwards.
Wow.
And typically, because our system is so simple, it's sort of like PV, local contractors can install it, and local people can take care of it. So it's that simple.
So full turnkey delivery. Very,
Yeah.
very impressive. Time to project realization, especially in the US, is a big topic. Interconnection queues, jamming up everyone, 4 plus 5, 6 years, especially in like PJM and CAISO areas like that. Does the fact that your system provides dispatchable synchronous generation give you like a free pass or a fast pass with grid operators? Are you stuck in the same line as intermittent renewables that are getting out of?
We don't like grids. By that, I don't mean we don't play nicely with them because we do. Our turbines, which is the source of power, and therefore is the interconnection with the grid, are from Capstone organization, Green Energy Company, based in California. They sold 10,000 of these around the world with a reliability of 97%. And what I mean by that, they operate 97% on average of all the hours in the year. 10,000 of them, high reliability. But the point is they connect nicely to the grid. And when the grid goes down, they keep operating. When the grid comes back up, they stop or interconnect or do whatever they need to do. But our systems are what we call standalone. Now, the one in India is going to be connected to their grid because they're buying the power. So it's okay with us. But by being off the grid, we can serve people now without having to connect to the grid, and so they don't have to wait. And that's a very, very important value proposition to many companies today.
Data center hyperscalers we were mentioning earlier.
Yeah.
Well, speaking of, we're seeing this resurgence of interest in 24/7 clean power matching. That's become a hot term in our business from those hyperscalers, Google, Microsoft, Metas of the world. Have data centers emerged as a viable off-taker for your tech? I mean, I know we mentioned, of course, they're interested, but especially given their need for that flat round-the-clock load.
But we think that's the most important thing we offer them right now
Mhm.
is power now,
Yep.
not in the future. And then all the other benefits of being clean and reliable and lower cost. I mean, we just think we're a natural fit.
I tend to agree. We mentioned at the top, you've been in this business for a while, you've been in PV, you've seen this learning curve that exists where the costs of solar components and of battery components have like 90% in a lot of cases dropped, right, over time. Since your system relies on more mechanical components, turbines, mirrors, etc., do you think you have a similar path to cost reduction as you scale manufacturing?
No, we'll never get to 90% reduction in cost because of what you just said. It's mechanical equipment. We'll get it through a lot of other ways. One is that we're increasing the size of each of our modules, just like wind turbines have increased in size over time.
Yep.
That drives down the cost. Another are engineering improvements, construction improvements, deployment improvements, working with manufacturers to, in a sense, it's called engineering for manufacturing as a way of driving down cost, integrating components off the site and bringing them more integrated into the site. Larger projects will mean larger purchase orders, which mean lower prices. And so continuously over time, we'll drive our costs down, but it won't be 90%. We have visibility on at least 50%. And as we close in on that, we'll see visibility to more, but I can't predict what it's going to be.
There's nothing wrong with 50% reduction in cost. You know, this show's called The Future Current. If you look out into the future, Bruce, and you've been predicting the future for a while now, having been in this space, 10 years down the road, what percentage do you think of the firming capacity will be coming from like thermal CSP versus, I don't know, hydrogen, long duration batteries, nuclear, geothermal, other? Is there a world where thermal, CSP is a meaningful portion of that mix?
I believe that in emerging economies, which is where we are most appreciated and have more success, you'll see a lot of CSP there. And, one of the things that we don't completely appreciate in this country is that we have almost no outages except during really bad storms. I mean, we do, but not very, very often and very widespread. There are countries that have outages every single day.
Yep.
They just don't have enough electricity. And they're not going to build nukes. They're not going to build gas turbines for all the reasons that you and I wouldn't want to. Not, and they're expensive. They would get them trapped in a high cost energy world that's disappearing in favor of low cost renewables. They just don't want to do that if they can help it. And they, just like cell phones jumped over and hurdled over, landlines, they want to hurdle over the old way of producing energy. And they want to emerge into a new world where the continent is making what they need, not being mined for their minerals, sending them off someplace else, and then importing the products that result. They want to do all that in Africa and require lots of electricity and a lot of industrial heat.
Well said. If you could step back into the 70s and visit the MIT campus and tap your younger self on the shoulder, what's the one piece of advice you would give to young Bruce Anderson about the future, the energy transition? What would be your advice you'd give to him?
Well, I was very impatient back then.
The only young person ever like that.
Exactly. And, it was frustrating to get this transition underway because there's so much momentum. I remember being the only clean energy person in a room with senior fossil fuel executives. And I don't remember being very nice, but I just realized then I went, oh my God, this is going to take forever. So I guess I'd caution patience, that young person. I might also caution them to avoid the lesson that I learned in a really hard way. And that is when President Reagan came into office, he terminated the solar tax credits, which immediately literally destroyed the solar industry, if you can call it that, at that point. So we had to start all over after he left. And it's been nice to see that coming in advance. There's a couple things like that.
Yeah, that would have been very nice to know that was coming, and a few of those cycles have come ever since. Well, you know, change happens gradually and then all at once, and I feel like we're entering that all at once period. And I think owe a lot of thanks to folks like you, Bruce, who are in the early days putting in time and effort and often thankless times. So appreciate that. I mean, it's got to feel good to sit where you do today and see how far it's come, and especially here in the U.S.
Well, I appreciate that. I can't tell you it's been all fun, but it is satisfying.
I love it. I love it. Bruce, was there anything I didn't get a chance to ask you about today that you were really hoping to make sure people understood about 24/7 solar and what you're trying to do with concentrated solar power?
No, just I think people should know that our team really loves solving people's energy problems.
Mm,
And, that's what we get up for, keeps us going every day, floats our boat.
that's beautiful. For those who would like to learn more about 24/7 solar, connect with you, where's the best place for them to go?
Well, they can contact me.
Bruce, it's been an absolute pleasure getting to speak with you today, getting to know you and understand a sector of the business that I didn't know a lot about before today. And it's been really eye opening for me. And so thank you for your time. Really appreciate it. Wishing you a lot of luck with the pilot project, and I'll be tuning in to see where you take it.
All right. Thanks.
For all my listeners, thanks for tuning in to another episode of Future Current. I'll see you next time.